Okay? This guy, well, what's one of these? That's an x squared. I have another x squared. So there's two x squareds. I have minus x and a plus x. So how many x's do I have? None. That's a wash, right? I have a minus x, a minus x, a minus x, plus x, plus x. How many x's do I have? So that's the polynomial represented by these pictures. Okay? So, on to today's. Okay, in previous math courses, that means you guys, learned how to multiply two monomials. What is x times y? xy. Okay? Is that two monomials multiplied together? Sure. Of course, you got bigger ones, but that's all it's saying. A monomial times a binomial. You've done this before. Only now we're going to do this with some algebra tiles. Okay, so first a little bit of this. This is how we set this up. Okay, one of these things that's multiplied is on one of these sides, and the other one's on the other side. What is this? Again, that's an x, sorry, that's a 1 and a 1, so that's a representation of 2, right? And over here, that's an x, that's a 1, so that is x plus 1. Okay? So if we want to know what happens when we multiply these, all you have to do is basically fill in the blanks here. If I take this and I multiply it by that, and I do this neatly, here's what happens. I get this shape. Does it look like it fits there nicely? That's all you do. Okay, this times this, what looks like it fits here? That shape. And you can ask yourself, well, what's 1 times 1? It's 1. What's 1 times x? It's an x. But remember, I got to shade this thing in, right? Okay, because these are all positive. Okay, what happens here? Now I look in this column. This times this, 1 times x, is x. Nice and neat. Looks like it fits in there pretty good, right? 1 times 1, well, I just did that. It's 1. Okay? And that's positive, so we're going to shade that in. What's the product? This is the product. And the wording in the book's going to say, what's the product in x? Well, that's the variable we have here. It's x. So that's the product in x. What is this? Well, I have an x, I have an x. That's 2x, and I have a 1 and a 1. That's 2. So when I multiply 2 times x plus 1, that's what I get as a product, 2x plus 2. Okay? Symbolically, there it is. It's like a picture for this. X. Here it is. Okay? X plus 3. X plus 1, 2, 3. There it is. Okay? So this, one of these goes on one leg. Sorry, I don't want to confuse you with triangles. Okay? The other one goes on the other side. What's the product? That's what we're going to get here when we make a nice rectangle. By the way, this always, you notice the nice lines I have here? Okay? It's always going to make a nice rectangle. If it doesn't, either you're really, really messy or you did something wrong. If you finish here and there's a big gap, that's your indication you did something wrong. Okay? Just look at the lines here. What looks like it fits here? Yeah, see this line? We're going to do that right across. You see this line? We're going to do that right across. And think of it this way. What's x times x? Is that x squared? Yes, it is. Okay? X times 1, what looks like it fits here? Something like that. X times 1 is X. X times 1, yep, that's still X. Hey, what's X times 1? Isn't that X? Yes, it is. Okay? These are all positive. So we're going to shade them in. Now don't spend all day doing this, right? If you got your pencil and your book, guys, here's all you're going to do. Okay? There, it's shaded in. This isn't art. This is math. Don't waste your time going. Okay, hang on. Just hang on. No, oh, missed a thought. Okay. Give me about 15 minutes and I should be done here. Okay? Shade it. Shade it. That's all you want to do. On a test, that's all I expect. Don't waste your time. Okay? Got better things to do. Okay, I just got my cool marker. That's why I like to spend time doing this. Okay? There we go. All right? What's the product in X? What is here? I have an X squared and 1, 2, 3 X's. Okay? That's the product. It's nice to think of this as like area. Okay? If I take this length, sorry, this is a length, and I multiply it by the width, I get area. That's the same concept. All right? So now we got some negatives. All right? -3, there's a -1, there's a -1, there's a -1, that makes -3. This is X positive -1 here. Okay? What shape looks like it goes here? Looks like one of those. Looks like I got another one. Looks like I got another one. And then you ask yourself, what is X times -1? -X. So I don't want to shade those in. Okay? Negatives, according to my book, are unshaded. Okay? -X, -X, -X. What's -1 times -1? First of all, looks like it makes that shape, but what's a minus times a minus? Positive. So I want to shade those. +1, +1, +1. Does it make a nice rectangle? That's your sign that you did it right. Okay, it's nice and neat. All the lines line up. Okay, here, here, here. Okay, nice and neat. What's my product? I have -1x, -1x, -1x. That's -3x and 1, 2, and 3. There it is. If you can draw a nice, neat picture, you can get the answer with this stuff. Okay? By the way, algebra tiles are physically actually little pieces of plastic. We don't even have any at the school. Haven't got any yet. Other schools have them. Okay? You should have seen it in 8 and 9, but I know here we don't do that much. Okay? Let's just go on to this guy. Let me use red. Okay? X minus 1, there's an X, there's a -1. 2x, here's 2 X's. What's the product? Let's find out. What looks like it fits here? An X squared. Is it positive or negative? What is X times X? Positive. Let's just shade it like that. Down here, X times X. I got the same thing. X squared. Okay? There's a gap here. I'm not done. What is X times -1 minus X? So I'm not going to shade that. And here I have the same thing. Not going to shade that. What's my product? Have a look. What do you got here? I have 2 x squareds and 2 negative x's. Okay? Any questions on that? Is anyone asking themselves, why the heck are we doing this? Hold that thought. One more. Now, what are we doing? We're giving you the area, and we're saying What's the length and what's the width? Okay, we're giving you the product. You got to find out, okay, what are we multiplying to get this? Well, again, what looks like it fits here? Looks like an x to me. Okay? What looks like it fits over here? Looks like an x. Okay? And let's shade that in, make it a positive x. Okay, because x times x, positive, gives you positive x squared, right? Okay? Well, if I got that, I must get the same thing here. X times x gives me positive x squared. What looks like it fits down here? A little tiny square, which means that's an integer. Positive times a negative, does that give me a negative? Okay, so I want to leave that like that. Okay? That could be the length, that could be the width. But, did anybody notice something? What happens if I have a negative times a negative? That'll also work, won't it? And that, of course, is the same thing. If that's negative, and my answer is negative, I'm going to have to multiply it by a positive. Okay, so I got two options here, don't I? There's two options of what I times to this polynomial times that polynomial gives me this product. And this polynomial times that polynomial also gives me the same product. Okay? State the polynomial represented in each of the diagrams. Well, what is this? That's 1x squared, 2x squared, minus x. Complete the left side and top and write the polynomial product. Product means something multiplied by something else, right? Well, I already did that. What do I have here? If I get an x and I times it to a 2x minus 1, I have to bracket that, right? Actually, let's bracket both. Why not? That's what I had there. But there was another option, wasn't there? If I do this on the right, complete diagram 2 and write a different polynomial. Negative x times negative 2x plus 1. I got the same thing. Write each product, that's here, as a sum or difference of terms. Is that a sum or difference of terms? Yeah, that's a difference of terms, okay? So I always get this question, Mr. Watson, what the heck does this mean? Okay? It just means multiply this out and see what you get. That's a difference of terms, isn't it? Okay? So this, if I multiply this out, I know how to do this. This is called, what is it called? Hold that thought. I got to multiply everything outside the brackets by everything in the brackets, right? So that's 2x squared minus x. Have we seen that before somewhere? Hey, looky there. Better work, right? If I do this one, well, I should get the same thing. What's a negative times a negative? Yeah, x times 2x is 2x squared. Negative x times 1 is minus x. And these are the same. Okay? And we should expect that because remember we started with the same picture here, right? 2x squared minus x. Okay? So there's a couple options there, right? When x is 3, verify these. Well, what they're saying is, if I put x is 3 in there, x is 3, make a substitution. Do you want a bracket when you make substitutions? Okay, a couple days ago I just had my Math 11 pre-calculus test, and kids who forgot that got several questions wrong just by not putting brackets in when you substitute. So do it. Do it, do it, do it. Always, always. Okay? So x, I substituted x is 3 here. I substituted x is 3 there. Put in brackets. All right, let's be consistent. Put them there too. Okay? So what is that? That's 3 times, 2 times 3 is 6 minus 1. What's 6 minus 1? 5 times 3. Let's just write it out. That's 15. Okay. Do I get the same thing if I put x is 3 here? Let's find out. It says these are equal, so I'd better. How do I do that? Bedmass. Right? Remember exponents? Do this first. 3 times 3, 3 squared, that's 9. Times 2 is 18. Take away 3, is that 15? You bet. Okay? Check. Verified. Okay? Doesn't matter. This is equal to that. Same thing with the second one. I'm not going to do it. What is this called again? Oh, look. Can you see that? Probably not. That's called the distributive property. Do you have to know that? No, you don't. Am I going to ask you on a test, what is this called? No. But it's nice to know what you're doing. You just got to make sure when you see this, you can get the answer. So here it is without algebra tiles, right? How do we do that? Everything outside the brackets is multiplied by everything in the brackets. Remember this exponents when we had that? And I said to you, that exponent of 3, what does it apply to? And you said to me, come on guys, everything in the brackets, right? This applies to this. Hey, we're going to have a midterm on this pretty soon, right? And it applies to that. It's the same thing here. Whatever you're multiplying this by, everything in the brackets. I don't care if you have 17 things in the brackets. This x is multiplied by every one of them. Okay? And if these little arrows help, then do it. So that's 2x plus 2. Let's backtrack a bit. So when we got these right at the start, did some of you guys look at that and go, well, why isn't he just writing it out like that? 2x plus 2. There it is. Why do we have to make this big picture? Because there's going to be a couple of these on the test. And you're not going to have this. Okay? So yeah, if you get that, great. Why do we teach this? Because some people, this really helps when we have a picture here. Okay? Negative 3 times x is negative 3x. Negative 3 times negative 1 is plus 3. Okay? So we should still check it that way even when we get the picture here. All right? But this will be like something on the government exam. They'll say, what is that? What's the product? You got to know what the answer is. Okay? All right, I'll just do one more. Let's do this. Do you like looking at it like that? Or do you want to rewrite it just by switching? Because 3 times 4 is the same as 4 times 3. I don't care. If you like this way better, then just rewrite this. You don't have to do it like that. Okay, this is the same thing. Put the monomial first, the binomial second. A lot of you are probably more likely to get the answer. 2x times x, 2x squared. 2x times negative 1 is minus 2x. Okay? Do you get the same thing this way? Sure. Okay? But like I said, you want to rewrite it, go right ahead. Okay, this is called distributive property. I don't care what A, B, and C is. You do this every time. Everything outside the brackets just a, is multiplied by everything in the bracket. So a times b plus a times c for any values of a, b, and c. That's it in general. Okay, that's what you do. That's called distributive property. Okay? Now if you want to think of it backwards, be my guest. Doesn't really matter. Okay? So, 4 times 3x, 12x. 4 times 1, 4. Okay, you should have done a lot of this in grade 9. A monomial times a trinomial. You do exactly the same thing, you just got one more term there, right? Negative 5 times 2x squared is negative 10x squared. Negative 5 times x minus 5x. Negative 5 times negative 6. What's a negative times a negative? Positive 30. Okay? I still have a trinomial, it's just a bigger one, because I multiplied that monomial to everything in there. Monomial times a binomial. Okay? What's x squared times x cubed? Are you multiplying with the same base? Add the exponents. 3 and 2 is 5. And minus 2x squared. But like I said, if your brain really likes seeing it like that, feel free. Okay, just rewrite it if you like it like that better. Okay, negative 3 times 7x. Just look at the numbers. What's negative 3 times 7? Negative 21. What's x times x? X squared, right? Same base, add the exponents. What's 1 plus 1? 2. Okay, negative 3 times negative 2, positive 6. X times y, xy. Negative 3 times 1 is negative 3. X times z, xz. Same thing. Okay? Every one of these has been written as a product of polynomials. That is a sum and a difference of terms. Okay? So I know the book says this, and people ask me, you know, even the A kids, what are you talking about? That's what we're talking about. Just multiply it out. Okay? That's written as a sum and difference of terms. Okay? So is this one. That's a sum of two terms. This is a difference of two terms. Don't get confused. Expanded is another word for multiplying. Okay? Multiply it, expand it out. Okay? This we just saw a minute ago. Same thing. I already said that. Exponent rule. Okay? Expand and simplify. What do we do with a 6? Not much. It's just 6. What are we multiplying by everything in the brackets? This negative 4 is times 8x. Negative 4 times 8, negative 32 times x. Okay? Don't try to multiply the 6 by the brackets. It's just 6, right? Okay, negative 4 times positive 1 is minus 4. Now we can collect it and simplify it a bit. Do I have some like terms here? Yeah, what's 6 take away 4? 2. 2 minus 32x. Okay, is this the same thing as this? Is one righter than the other one? No, that's the same. But usually we want the positive one first. Okay? But if you write it that way, it's not wrong. But just keep in mind, if this is a multiple choice question, that'll probably be one of the answers. They probably won't have that one. So if this is how you see it, you got to make sure this, you know that's the same as this, right? Okay, they get bigger. They get uglier. Oh no, what do I do? Exactly the same thing. You just do it twice. Okay, 4 times 2x is 8x. 4 times negative 3 is minus 12. Negative 2 times x minus 2x. Negative 2 times negative 6, positive 12. Am I done? Can I simplify it? Yes. Do I have some like terms? Yes. 8 fish. I lose 2 fish. I got 6 fish. What's minus 12 plus 12? Had 12 bucks, spent 12 bucks, got no bucks. Okay, but I got 6 fish. You know what? Let's just skip that, because I want to get to this cool stuff. Okay, last one. Determine a simplified expression for the area of the shape. Remember, every one of these questions I said think of area. That's like area. Okay? Length times the width is the area. We're going to get some area things in here. I know it's not measurement chapter. Okay? What's the name of this shape? Blah, blah, blah. We don't know. I don't know. There's no formula for the area of that shape, even if I know what I call it. But I do know the formula for the area of a rectangle. Okay? So, let's add the areas of 2 rectangles. Now, there's a choice. Do you want to split it? Don't write this, because that's not how I'm going to do it. Like that, and add this area and add that area? Sure, that's one way. Or do you want to split it like this and add that area and add this area? Sure, either way will work. Okay, the area is the same in both cases. So let's do it that way. All I need is the area of this piece. And what's the formula for area of a rectangle? Length times width. So the area of this one is 3x plus 2 times 2x. Okay, that's this piece. But to get the area of the whole thing, I need to add this one. Okay, so I need to add the length times the width. What's the width of that one? If you see it, don't yell it out. It's not given. Okay, we've seen one like this already, right? Have we? Can't remember, because I get this course confused with the other math courses. Well, you got to think. Think. There's 2x. She's green. Here is 4x. Do you think this is the same as this here? Yes, it is. So that's 2x. So what's this length from here to here? It's 4x minus 2x. Okay? That's hard to, like, if you don't see that, it's really hard for me to explain that and stick that in your head. Okay? So hopefully you do. If you don't, ask me after and I'll say it again. Okay? 2x plus 2x is 4x. That's this whole length. Okay? So that's 2x. This is also 2x, right? Because these are right angles here. Okay, so length times width of that piece is that area. All I have to do is add these together, and that's the total area. Again, if you don't like to see this way, then write it the different way. But this area is 3 times 2 is 6. X times x is x squared. 2x times 2 is 4x. 2x times x is 2x squared, and 2x times 5 is 10x. That's the area of this combination of rectangle shape. Can I simplify it? Then you do it. I have 6x squared and 2x squared. That's 8x squareds. I have 4x and 10x. That's 14x. That's the area. Okay? That's just one way to do it. Look at the other way. This is the same shape. Could I do this by subtracting? How about I just calculate the area of the whole thing and then subtract that little chunk? Would I be left with the area of this? Yeah. And if that's the way your brain works, then you can do it that way. Okay? So the area, this is just the concept, the large minus the cutout, if you will, and I'll be left with the area of this shape. Okay? So what's the area of the big thing? Length times width, 3x plus 2 times 4x, and now I got to minus this little chunk. What are the dimensions of that chunk? Well, remember I already found this length, right? What's 4x minus 2x? That's 2x. What's this length here? Let's do that in blue. Whoop. Okay, this thing is this length minus that length. Okay, so that's a little bit of work first before we do it this way. I think this way would be easier, but let's just see if we get the same thing. I made a mistake. What was it? If I go this, subtract that, what do I have to do here? If you don't do that, it's going to be wrong, right? This piece minus this piece, not just part of this piece, minus the whole thing, okay, is going to be left with this chunk right here. If I don't put brackets, I'm not minusing the whole thing. I'm just minusing part of it, okay? So I got 3x plus 2 minus x. That's the only way this will be minus 5, okay? You just have to do it. Try to remember that. 3x minus x is 2x. 2 minus 5 is minus 3. That's the length of this right here. Okay? That's what this is. So the area of this chunk that I have to subtract is 2x times 2x minus 3. Let's see what we get. 12x squared plus 8x minus 4x squared plus 6x. How many x squareds do I have? 12 take away 4 is 8x squareds. And how many x's? 8 and 6 is 14. Have we seen this before? It better be the same area, right? It's the same piece. When you're doing these, if you get a question like that, one way is usually easier than the other way. How do you know beforehand which way is easier? Because this took a little bit of work. It was probably a little harder. You don't. There's only one way to find out, and that's to do it both ways. Okay? So if you like adding, that's the way you're going to do it. If you like subtracting, that's the way you're going to do it. You get the same answer either way. Okay? So 1 to 2, both of those just ABC, those are the algebra tile ones, okay? 4, you know what I mean by odds now, right? 4 odds. Okay, that's like A, C, E, G, so on and so on. 6, 7, A, C, E, 8, and 9.